Hello students, welcome to Sunya IAS. So today we are going to discuss this particular topic called mixtures and alligations. And so this is a very basic, very easy topic. There is no concepts here which we have to study new. What we have to do is to just apply all those things which we learned in previous topics such as percentage and ratio and proportion. And you know, most of all the common sense which lies here in our skull. So that we have to use also. And one basic thing which I would like to tell you about this particular topic is that here we will have to use one habit and make a part of our calculation process from this chapter now on, that we must make diagrams. So suppose if there is a question which says there is a solution which is of 1 liter and in it you actually have a liquid called liquid A. Okay, let's assume it to be water. Then what is happening is that, let me just color it also, that suppose that liquid A is nothing but water. And so in this we take out some amount. Suppose we take out this much amount. Let me just use a pen. We take out this amount. Let's call it 300 ml. So how much of solution will be left? Definitely we will be left with 700 ml of water. Right? So what I am doing, I am just representing the basic information in the form of a diagram. Now let's say the person is saying, now you have removed this 300 ml. Now further you have to add 300 ml of milk. Initially there is water. Now you have to add milk. So let's say this yellow color represents milk. And now you are adding 300 ml of milk here. And this is water 700 ml. So how much is the total volume of the solution now? That would become 700 ml plus 300 ml, 1000 ml, or you can also write it like this, 1 liter. Now out of this 1 liter, what is the proportion of milk in it? So milk in it is 300 upon 1000, that is 3/10th part. Similarly, if we talk about water and I ask you how much is water in this particular solution, that would be nothing but 700 upon 1000, that is 7/10th part. Okay, so I am just for your ease showing milk and water in two separate layers. Actually this is a mixture, so all of them are actually mixed, but so that we can easily visualize through this diagram, we have just separated them as different layers. Just like a layer of oil, collects on the top of a layer of the volume of water. Similarly, we are assuming milk is also showing the same behavior, just so that we can easily represent and try to understand the whatever information is given to us via these diagrams. And this is something which you have to learn about. So let's say now you have this particular solution or mixture with you, okay, in which milk and water are mixed. If I take out from this overall solution, if I take out 100 ml, if 100 ml of mixture I take out, can you tell me the quantity of milk in it and the quantity of water in it? So that would be easy. How much milk is going to be in this particular 100 ml? So in the total solution, milk is 3/10 parts. So here also milk is going to be, out of this 100 ml, we'll just multiply 100 ml into 3/10. You will get 30 ml as the quantity of milk in this 100 ml part which you took out from this original solution. Similarly, if I ask you how much is going to be the amount of water, you can say that out of this whole 1000 liter of solution, only 7/10th part is water. Similarly, if you take out this 100 ml again, out of this 100 ml, you will have 7/10 parts as water actually, and that would be nothing but 70 ml. So is it clear to you now? It is the process, the modus operandi which I am going to explain to you here. this is the approach we are going to follow in each of the following questions we are going to see ahead. And believe me, all of them are very easy questions. You can easily solve them. And so please do not get afraid, do not get, chickened out of whatever you are seeing here, or just by looking at the CSAT question, do not make the impression, right? Just try to give a fight, try to understand, try to, learn, adapt, improvise and overcome. That is the way. And so here we have our offline and online hybrid course. Here we have covered exhaustively the topic of mixture and alligations. And this is a very good question because recently questions are being asked. So we'll begin with our discussion now. We'll begin the discussion of our problems. So each of these questions are very easy. What you have to do is to just understand the thing which is going on here. So let us read the question. So 30 gram of sugar was mixed in 180 ml of water in vessel A. So suppose we have a vessel A. In it, we have 180 ml of water. Let me represent it with blue color. And now in this we are adding sugar. Let me represent sugar by, let's say, this green color. So we are adding sugar, and this sugar is how much? 30 gram. Okay, so we have actually mixed it. I am just showing it in a different layer. Similarly, you are having different vessels. So you also have in this way a vessel B, and also you have a vessel C. So I am just drawing these vessels. This is vessel B, and this again in the corner is vessel C. Okay. Now if we talk about vessel B, what is given? The information given to us is that 40 gram of sugar is mixed in 280 ml of water. So suppose this is some another vessel. Here we have 280 ml of water, and in this 280 ml we have added sugar in how much amount? So we have added sugar as around 40 grams. And if you look at the final vessel, which is vessel number C, you will see that it is actually 100 ml. So we have 100 ml of water here, and in this 100 ml, how much sugar you are going to add? You are going to add 20 grams of sugar. This is nothing but 20 grams of sugar, right? So what we have to do is, finally I have represented all the information given to me in this graphical or diagrammatic form. If you are clear with the diagram, you can actually proceed with the question. Otherwise, if you are just stuck in the language part of it, you will be nowhere to go. You will be so confused. That is why it is good to make diagrams in such questions. Now moving on, it says the solution in vessel B is sweeter than that in solution C, sweeter than solution A, as sweet as solution C, or less sweet than solution C. So basically they are comparing the sweetness of the solution. Okay, so how can you compare the sweetness? Suppose you have a small glass in which you add 2 spoonfuls of sugar. It will be sweet, definitely. On the other hand, you have a big jar, and in that you have completely filled it with water, and then you are adding 1 spoon of water. Definitely it is going to be less sweet as the sweet solution we had in the glass. That is the basic idea. So if the volume of water is more and the quantity you are adding is less, obviously it is going to be less sweet. That is the basic idea which you have to follow here. So here, if we look at the first case, if we look at A, we have 30 gram of sugar dissolved in 180 ml, and we can simplify it further as 1/6 gram per ml. If we look at solution number B, in B we have 40 gram of sugar in 280 ml of solution, and therefore we have 1/7 gram per ml of sweetness in this particular solution. And when we talk about vessel C, we have 20 gram of sugar in 100 ml, and we can further simplify it like this, 1/5 gram per ml. So here you can see we have actually got the concentrations or the quantity of sugar in each of the solutions. So here we have 1/6 gram per ml amount of sugar in A, 1/7 gram per ml amount of solution in B, and 1 by 5 gram per ml amount of solution is there in vessel number C. Now, just a quick question. Out of these three fractions, 1 by 5, 1 by 6 and 1 by 7, can any one of you tell me which one is going to be the greatest and which one is going to be the smallest? Can you tell me? Just think for a moment, it is a very easy question. So here one can say that this 1 by 5 is actually going to be the largest value because 5 here in the denominator is the smallest. On the contrary, 1 by 7 is going to be the smallest number of all the three because this denominator here 7 is the largest of all the values. So one can say the least value is going to be 1 by 7, then 1 by 6 will lie somewhere in between, and finally we will have 1 by 5. So 1 by 7 is the concentration of nothing but B. 1 by 6 is nothing but the concentration of A. And finally 1 by 5 is nothing but the concentration of C. So here we have the order of concentration. Here you can say B is not sweeter than C, so this option is ruled out. B is not sweeter than A, this option is also ruled out. It is not as sweet as C because there is no equality sign, this is also ruled out. Finally we have option number D, that it is less sweet than B, that is the final answer, and so we'll mark the option D as the correct option. So here you can see what we did is we did not had any formula, anything. We just used basic common sense. And how can we solve such a question easily? By drawing the diagram. Okay, I just cannot lay enough emphasis on the diagram part of it. That is something very important, very crucial. Now this is a very easy question. We have two glasses of same type, so they are equal in size. So suppose we have two glasses. This is glass 1. Let's assume its volume to be 1 liter. And suppose we have a second glass. It is also 1 liter. And they are respectively 1/3 and 1/4 full of milk. So if you represent milk with say orange color, this is milk. Here 1/3 of this glass is full of milk. So here is milk, and it is, since it is 1/3, obviously it is going to be 1/3 liter. Okay, let me write it in red. Here it is going to be 1/3 liter. If we talk about the second part, here 1/4 is full of milk. So suppose this is the full part, then this will be the 1/4 of the portion, and it is full of milk. So 1/4 of 1 liter is nothing but 1/4 liter. So 1/4 liter is nothing but milk. Now what you are doing, they are filled up with water. Completely we are filling them up with water. So what we are doing actually here is adding water to the top up to here. If 1/3 is already filled, water will occupy this much space, that is, it will occupy 2/3 liters of space. Similarly, in this part, we can say if we fill it with water to the top, water will have so much space to occupy, and therefore it will occupy 3/4 liter. Is it right? Now, what we are doing is that this we have done, they are filled with water up to the top, and now the contents are mixed in a pot. So what we are taking this glass also, and we are mixing them in a pot together. So what is the ratio of milk and water in the final pot? So what is basically happening in the pot? You are adding this milk and this milk, this water and this water. You have to finally tell the ratio of milk and water in the pot. So let us talk about milk first. How much milk is going to be there? So milk is coming from this portion and that portion. So milk is here 1/3 liter and there 1/4 liter. If you try to add them up, you will take 12 as the LCM. You will get so and so values. Here you will get 4. Here you will get 3. Overall 7/12 liter is going to be the amount of milk. If you are not good with this addition of fractions, you need some basic help. These are the basics which will be applied everywhere, not just this particular topic, but in each subject, each topic of quant. So please, we are actually helping such students which are weak in this basic part of adding fractions, subtracting fractions and so on. So you have various options available with us. Now moving on, this is the amount of milk. What about water? So water is present here also and here also. Here we have water as 2/3 liters and here we have water as 3/4 liter. If you take the LCM, you get 12. Overall here you will get 8. Here you will get 9. You will get 17 upon 12 liter as the amount of water. That is clear. So if you want to find the ratio of milk and water, that is going to be nothing but 7 by 12 is to 17 by 12. Just cancel out the 12 from both sides. You get 7 is to 17 as the final answer, and that is nothing but option number A. That was also a pretty easy question. And if you draw the diagram, see, if you are not drawing the diagrams, all of it will look like, a mess. But if you draw this, everything will be a cakewalk. There is nothing much of a calculation, just some basic adding of fractions and nothing else. So please help yourself with that. And now we have a third question, which is happily very similar to just what we did. So please read it once, and I will urge you to at least try to solve this particular question by yourself, because we have done a very similar question just a few seconds ago. Okay, so give it a read and then we'll move on. Okay, so two glasses of equal volumes are respectively half and 3/4 filled with milk. Same thing like earlier. So we have two glasses like earlier. Let's assume them to be 1 liter and 1 liter. And one of them is filled half with milk. So milk, again we are taking half here, and here we are taking it to be 3/4. So here it is 1/2 liter. Here it is 3/4 liter. They're filled to the brim by adding water. So you are filling them till this top by adding water. Here also and here also. So here we have how much? Same half liter of water, and here we will have 1/4 liter of water, right? Their contents are poured into another vessel. Now what you are doing, you are taking both of these glasses again and mixing them in some another pot. And now what is being asked, what will be the ratio of milk to water in this vessel? We have to find nothing but the ratio of milk and water like we did previously. Nothing new we have to do in this particular question. Okay. So here how much milk we are going to have? We have half liter from here and 3/4 liter from here. Take the LCM as 4. You will have 5/4 liter as the value of milk. Similarly, if we talk about water, how much water is going to be? So water here is 1/2. Here water is 1/4. Overall you will get the value of 3/4 liter. So if we want to take the ratio of milk is to water, milk is nothing but 5/4 liters. Water is nothing but 3/4 liters. Overall ratio is coming out to be nothing but 5:3, and that is option number D. So this question was clearly a very similar question to what we have seen earlier. So this kind of pattern repetition is, a common thing with UPSC. So please pay attention to the thing we are covering now. We are covering the previous year questions, and these are the most crucial questions which you should attempt by yourself, and now follow whatever we are doing here. Okay, so now we'll move on with this question. There is a milk sample with 50% water in it. Okay, so what is happening here? Suppose we have a sample in which there is 50% water. So it basically says that in this sample, half is milk and half is water. So suppose whatever quantity is there, this will be milk, and the remaining half would be water, right? Now what we are taking, just read the questions ahead. If 1/3 of this milk is added to equal amount of pure milk, so out of this total amount we are taking 1/3 of the amount. So 1/3 of the amount we are taking from here, and then you can say that in 1/3 amount also half will be milk and half will be again water. Okay, and now you are mixing it with equal amount of pure milk. So you are taking similar quantity again, and this you are taking as how much? Equal, it is completely full of pure milk, so there will be no such partition. All of it is actually milk. So whole of this glass is full of milk. Okay, so far is it clear? Now it is saying then water in the new mixture. Now we are just adding them up, so we'll have a final mixture in which there will be some milk and some water. Okay, so this would be milk, this would be water. The water will fall down to what percentage in the final solution that is being asked. So I have very beautifully shown the whole process in terms of diagram. So what we are doing here, we have some solution. Now one thing you have to pay attention to is that this value is given 1/3. Out of this total, we are taking 1/3. So suppose this is 3 liters. I am assuming it to be 3 liters. So that this portion is 1/3 of the total, it will become 1 liter only. And equal amount you are mixing, so this is also going to be 1 liter. Now, what we have to tell is the percentage of water in this new mixture which we are forming. So in the new mixture, what is the source of water? Water is coming only from this place, and how much it is going to be? 50% of 1 liter. It is nothing but 50% of 1 liter, that is 0.5 liter. And what is the total volume of the whole mixture? So from here you are adding 1 liter, here you are adding 1 liter, overall volume of the solution is nothing but 2 liter. If you want to find the percentage of water in the new solution, that would be nothing but 0.5 upon 2 into 100, and then overall you will get the value by getting rid of this decimal, 25%. So overall we can see initially water was how much? 50%. Now when we mix a portion of it with pure milk, you will get final value as 25%. So the percentage of water will actually fall down to 25%. That was the question. And as you can see, there is nothing much difficult about this question if you have got the diagram working for you. Okay, that is the process of approaching. Question number 5. So a bottle contains 20 liters of liquid A, and then 4 liters of liquid A is taken out and replaced by same quantity of liquid B. So pay attention to this part first. First we will focus on this part only. What we are having is that we are having a solution, we are having a liquid called liquid A, which is how much? 20 liters. And then we are removing 4 liters out of it. We are removing these 4 liters out of it. And then what we are adding? We are replacing same quantity, that is we are adding 4 liters more of liquid B. So what we are doing actually, we are adding 4 liters of liquid B. That is the thing we are doing. So if we overall carry on the whole process, we can figure out that out of this total portion, which is 20 liter, 4 liter you have removed. So we will be left with liquid A as only 20 minus 4, that is 16 liters, right? And now we are having one more quantity, that is liquid B. So suppose this is liquid B sitting at the top, and this liquid B is going to be how much? We added 4 liters of it, so now it is going to be 4 liters. So out of this total liter, 20 liters initially which was liquid A, we removed 4 liters and replaced it with 4 liters of some other liquid. So now we have this kind of a mixture. Okay, in this mixture we have 16 liter of A and 4 liter of liquid B. Is it clear? This is the first part of the line. Now here you can see that how much is going to be the ratio or parts of liquid A. So liquid A is going to be how much? Total 16 out of 20. So there out of total 20 liters, there are only 16 liters of liquid A. That it is nothing but 4 by 5 part, 4 by 5th part of the whole mixture. Then if we talk about liquid B, let me use a different color pen. So if we take a liquid, if we talk about liquid B, how much liquid is there? Out of total 20 liter, we have only 4 liter of liquid B. That would be nothing but 4 by 20, or on simplification it would be 1 by 5th part. So this is actually the breakup of the whole solution, whole mixture. In this mixture we have 4/5 parts of liquid A and 1/5 parts of liquid B. Is it understood? So very well. This is all we have discussed about the first part. Now we have to talk about the next part of the question, and that says again, so now I'm erasing this initial process, then I'm drawing it again. So this I'm erasing, and now here I am having a mixture in which majority part is of liquid A, but some part is also of liquid B. Okay, so this is a mixture. What you are doing now is again 4 liter of the mixture is taken out. So like previously we were removing 4 liter of the mixture, here again we are removing 4 liter of the mixture. Okay, and then we'll replace it by same quantity of liquid B. So we removed 4 liter of the mixture, and now we'll add again more 4 liters of liquid B. Is that process understood? That again one more time, the second time we are removing 4 liter from this mixture and then again adding liquid B. Is it understood? So here you can see, let me just create some more space on this part here which I explained it to you. So here we had a mixture, and in this mixture this was the ratio of A and B, the proportions, and then out of it we removed some part from B also, from A also. Overall solution we removed some parts. So this is the part we removed, 4 liter, and now we added more liquid B in the quantity of 4 liters. This is the process we are doing the second time. Now what we have to tell? We have to tell the ratio of quantity of liquid A to that of liquid B in the final mixture. That is what we have to do. Okay, so pay great attention to what I am going to do next, because it is very crucial, and same question we will see again in 2022 just next to it. So please give your complete focus. So let us talk about some basic things. Let us talk about liquid A first. How much liquid A was there initially? There was overall 16 liters of liquid A, as you might have known. What you are doing, you are taking out 4 liters of the mixture. So 4 liter you are taking out, but you all know that 4 liter is of the mixture. Out of it, all the portion is not of liquid A, only 4 by 5th portion is of liquid A. So I will multiply this value with 4 by 5. Okay, this is the quantity of liquid A in the mixture. If we try to find it, it is going to be, we'll just simplify it like this: 16 minus 16 upon 5. That would be nothing but 18 minus 16 upon 5. Or you can write it like this: 64, sorry, not this one, but 64 upon 5 liter. ठीक है? Now we'll talk about liquid A, and if you are not able to follow up, just wait, just carry on with the process. I will again summarize this whole thing once more for you. So now we'll talk about liquid B. How much liquid we had initially? So we added 4 liter of liquid B initially. So we had 4 liter. Then we took out 4 liter of the mixture. But out of this whole 4 liter, only 1/5 part, as you can see, is of liquid B. And after removing this 4 liter, we are 4 liter mixture, we are further adding 4 liter of pure liquid B. So again we are adding plus 4 liter of liquid B. It can further be written as 8L. So 4 plus 4, 8, minus this is nothing but 4/5 liter. We'll try to simplify the things. 5 is LCM. Ultimately, we get the quantity as 36/5 liter. So overall in this solution, we have found out the quantity of liquid A to be 64/5 and the quantity of liquid B to be 36/5. If you were not able to follow up that time, I am going to summarize it again once for you guys, because I know this is tricky part and this is the heart and soul of the whole question. So here you can see how much liquid A we had in initial stage. We had 16 liter of liquid A. Then what happened? We removed 4 liter of the mixture. Now in this complete 4 liter, only 4/5 parts are of liquid A. So we will multiply this by 4/5. On further simplification, we will get the value 64/5. Okay, that is clear. Let's talk about liquid B next. So we had liquid B initially as 4 liter from the first stage. Now you are taking out 4 liter of the mixture. If 4 liter of the mixture is taken out, since the mixture contains only 1/5 parts of liquid B, this much quantity 4 into 1/5 will be taken out. And now again you are replacing the same quantity with 4 liter of pure liquid B. So you are adding plus 4. Overall on simplification, we'll get the value 36/5. Okay, that is done. What is final thing which is being asked? The final thing which is being asked is ratio of liquid A to liquid B in the final mixture. So in final mixture, liquid A is to liquid B. The ratio we have to find out. Liquid A is nothing but 64/5 and liquid B is nothing but 36/5. Cancelling them out, you will get 64 is to 36. Further by a factor of 4 we can cancel them out. You will get 16 is to 9 as the final value. And so option number C is going to be the correct option here. So I know friends, this was a really good question and I hope you followed it up, because you can expect similar questions in the final exam also. And now here we are going to have the last question of the day, which is a really good question and a fresh question right from 2022. So just give it a good read. I want you to read the question, understand the question. If you do that part very well, then you'll be very good to go. And so I am giving you a small amount of time just to read this particular question. Okay, so pause your videos and just read it. Okay, so now let us read the question. There are two containers, X and Y. X contains 100 ml of milk. So let us draw. This is the container. This is the container X and it contains 100 ml of milk. Then there is a container Y which contains 100 ml of water. So there is another container called Y which contains 100 ml of what quantity? That is water. Now what we are doing, 20 ml of milk from X is transferred to Y. Now let us look at this process first. What we are doing, out of this 100 ml, we are taking out actually 20 ml and transferring it here. So what will happen? In this vessel X, you will have only 80 liters of milk left because 20 is removed. So now you will have, let me just draw on the sidelines, you will have 80 liter of milk, sorry, not 80 liter, but 80 ml in vessel X, you will be left with lesser quantity, that is 80 ml of milk. Now let us talk about water or this vessel Y. In this vessel Y, what you initially had was 100 ml of water in the beginning. And now you are adding 20 more liters of milk also. So here you are adding 20 ml of milk. So now the overall volume has become how much? 120 ml. So in this solution number X, we have only 80 ml of milk left, but here we have now a mixture in which 100 ml is water from initial, and then we have 20 ml of milk newly added, and so the overall volume will become 120 milliliters, right? Now let us try to figure out something about that second solution. So I am just clearing the space from here. I hope this first step is understood to you. And so here we have this solution. Here out of 120 ml, how much milk is there? Milk is 20 out of 120, that is 1/6 parts. And how much water is there? We have 100 out of 120, that is 5/6 part as water in this mixture. So this was up to this line, this process I have explained to you, and in the final mixture Y, I have told you the composition, 1/6 milk and 5/6 water as well. Now let us move on. After mixing well, 20 ml of the mixture in Y is transferred back to X. Now what you are doing, after the whole mixing, from this again you are taking 20 ml back to here. Are you getting the process? After this whole mixing is done, you are taking 20 ml from here and taking it back to there. So if you take 20 ml from here, suppose from here if you take 20 ml and put it here, this 20 ml will not only contain milk, but it will also contain water. It will be a mixture. That is clear. So now what we will do is try to then again figure out that how much of the quantity of milk was added in here, whatever was that we will try to analyze. So let me just create some more space. About this solution Y, I am just writing again for your information that the ratio of milk is nothing but 1/6 and the ratio of water is nothing but 5/6. Okay. Now what we have to do is that here we will talk about solution X and then we will talk about solution Y. So if we talk about solution X, what we have either, so we have milk. Initially we have 80 ml of milk, so 80 ml is already there. Then further what we are having, we brought 20 ml back from here, some solution, so we got 20 ml of solution more, but that whole solution does not contain milk, only 1/6 of it contains milk. So out of this 20 ml, only 1/6 is adding up to milk. Okay, let us talk about water in this particular solution. So if we talk about water, initially in this solution there was no water at all, so nothing to worry about. But then you are adding 20 ml from this vessel Y. So how much you are adding? 20 ml you are bringing from vessel Y. But out of the 20 ml also, not the whole, but only 5/6 part is actually water. And so if you try to simplify these values, here you will get nothing but 100/6 ml. And if you try to simplify these values, here you will get 80 plus 20/6. If you take 6 as whole LCM, you get 480 plus 20/6. That would be nothing but 500/6. So this quantity, after all addition and subtraction, is going to be 500/6 ml. Okay? Is this clear? So this is something I have written about the solution number X. Let me just put it in a box because it might be useful later. Now moving on, let us talk about solution Y. In solution Y, how much is the milk? Milk is, just coming from the quantity we initially bought. So there was, we bought 20 ml of milk, and that was mixed, and out of the 20 ml we again took out 20 ml of the mixture, but that 20 ml of mixture does not contain all of it as milk, only 1/6 portion of it is milk. So we can write the quantity of milk like this. Is it okay? If we try to simplify it, we'll get 20 minus 20/6, nothing but 120 minus 20/6 or 100/6. This is going to be simply nothing but 100/6. Similarly, if we talk about the quantity of water here, how much is water? Initially all of it was water, that was 100 ml was water, but then we took out 20 ml of the mixture, and in that 20 ml, how much was the quantity of water? 5/6 of it was water. So overall we can say the quantity we are going to have now is 600 minus 100/6, that is going to be 500/6 ml. Okay, so this is the quantity of water in solution Y. Just to sum it up again in 1 minute, what we are having is the whole process explained. Milk initially 80, you take 20 ml from here, only 1/6 part contains milk, you get this quantity. Similarly, water was initially absent, you take 20 ml here, 5/6 of it was water, so this is the quantity of water in solution X. Then we talk about solution Y. Milk was initially we bought 20 ml from here, and then we took out 20 ml again, but only 1/6 of the taken out part was water, so we get this quantity. And for water, 100 ml was water, you take out 20, and then out of the 20 ml, 5/6 portion was water, so this is the final value of water. Now what are we being asked? Let us focus on that last part, and the question will end and our discussion will end. And so here we'll have M is denoting proportion of milk in X, and N is denoting the proportion of water in Y. So we have two quantities. We have M, which is nothing but what is the quantity of milk in X, and then we have another quantity which is N, and it is nothing but water in Y. So how much milk is there in X? Finally, after all this process, milk in X is 500/6 ml, and now overall final volume is, you took out 80, then again put 20, so you have 100 ml here. So out of the total portion, you have 500/6 ml as milk, and the total volume of the solution is 100 ml. So the ratio of the value of M you are getting is 5/6. Similarly, if we talk about the second part, the water in Y, how much water is there in Y? Water in Y is nothing but 500/6. And how much is going to be the volume, total volume? So initially you add 20, then remove 20, it is left with 100 ml of water only, right? So here you have 100, by simple calculation you are getting the value of M as also 5/6. So M is 5/6, N is also 5/6. So one can say option number A, that is M is equal to N, is totally correct. So I know this was a very complicated question, very difficult question, but if you once figure out what we have to do, it will be a cakewalk. So the proportion of milk in X is also 5/6, the proportion of water in Y is also 5/6, and so we can say that the discussion was complete. And therefore we'll move on to the last part, that is thanking you guys for your support, for your patience, and for sticking around with these topics. And I know this is sometimes challenging for those who are not of mathematical background, but promise is there from my side that if you follow it good, you'll be good to go in CSAT, and nothing will stop you from, cracking that 33% barrier in your CSAT examination. Okay, so thank you guys.